Welcome back. In this video, what we're going to take a look at is the linear approximation. And what that means is we're going to take and use this line that's tangent to this graph. That's an equation of a line that we've looked at quite a bit so far this fall. And we're going to use that line to approximate values of f near A. So the further I get away from A, the approximations get worse. The closer I get to A, the approximations get better. And we're going to talk about how close they are eventually. We generally write this as like L of x equals this expression. But really what this means is just the equation of line tangent to the graph that you've been writing all fall. In my first example, you know the equation is the square root of x. I'm going to write the equation of the line tangent to the graph at x equals 1, and then use that to approximate f of 1.1. The first thing I need is the y value. If I plug in 1 in the original equation, I get y equals 1. And then the second thing I need is the slope. The slope is going to be the derivative at 1. So it's going to be 1 over 2 square root of x. At 1, it's going to be 1/2. And so the equation of the line is going to be y equals, it's 1, that y value, plus 1/2 times x minus 1. And we wrote it in that previous screen as L of x, like the linear approximation of it. That's fine. And then we're going to use that to approximate 1.1. So L of 1.1 is going to be 1 plus 1/2 times 1.1 minus 1. This in here is 1/10. So 1/2 times 1/10 is 1/20th. So it's 1 and 1/20th, or some version of that. If you said 1.05, that's fine. Okay, anything, that's all good. In my second example, in this one now I'm not going to tell you what f is, I'm going to describe f. So I gave you the original point, I gave you the derivative, I gave you the second derivative. You actually don't need the second derivative, it's given to you as kind of unneeded information. And I want to write the equation of line tangent to the graph at 1, so I'm going to use this point, this slope, and I'm going to use that to approximate when f is 0.09. So the linear approximation, L of x, is going to be my original point, which is going to be -2, plus the change, which is going to be a derivative of 2, times x minus 1. If I use that and I put in 0.9 right here, L of 0.9 is going to be -2 plus 2 times 0.9 minus 1. This in here is -1/10. I multiply it by 2, I get -1/5. So it's going to be -2.2, or some version of that. Any version of that works. All right, so this is not nearly as challenging as the related rate stuff. It draws on things that you're already familiar with. We'll see you in class. We'll clarify. Good luck.